take me a second to get the projector on. While that's warming up, which I think is warming up, a couple of quick things about this talk. One, I gave this talk originally in Japan, so if you see comics that are outside of the normal US comics, you know why. Second, I was originally developing this talk for folks who were brand new to JavaScript and started asking questions about it on, is it still not? Okay. On the Slack channel. So if you're not on the San Diego JS Slack channel, actually that's a great thing to check out. But folks were saying, hey, even though I'm not brand new to JavaScript, I'd be really interested in that because I know my slice. And I know there's all this crazy stuff that's going on in the ecosystem, and I want to hear about it as well. So hopefully even our JavaScript experts can get something out of this talk. Modern JavaScript. JavaScript right now in 2015 is very different than it has ever been, and especially from where it started. So let's start with turning on my clicker. And the question, why JavaScript? Especially why JavaScript now? If we look at GitHub as a measure of what's active in the world right now, we can see that JavaScript has become the most popular language in the world. One reason driving this is total number of websites in the world just keeps going up and up and up. Despite the shift to mobile, websites continue to be the most common thing that people are developing, and they're one of the most common things out there. And then even taking mobile into account, there was a survey this last year of mobile app developers, and HTML5 plus JavaScript and CSS was cited as the #1 development environment for native mobile applications. 42% of mobile app developers were developing in HTML, CSS, and JavaScript for at least part of what they were doing. So the question is then, great, okay, I know I want to do JavaScript, there's all this stuff, where do I start? I've heard about Nodejs, but wait, there's this thing called IOJS, what's that? And I need to know NPM and Bower, and then there's all these buzzwords, Grunt, Gulp, Broccoli, jQuery, Angular, Backbone, it just keeps going. Where are you supposed to start? So let's break it down a little bit. We've got a few things going on here. We've got execution environments, so there's browsers, generally speaking. Those are the traditional places where JavaScript runs. Node.js and IOJS figure into that as well as execution environments for JavaScript. There are web servers. Some of the buzzwords on there were Express and Happy. Those are web servers. Package management, task runners and build stuff, front-end tools, module systems, JavaScript flavors. This is still a heck of a lot of stuff, even trying to break it down a little bit. So let's break it down a little more. If you want to build a client-side application, something that's going to go on a phone or on a browser or on a web page, what have you got? You've got your application code. That's how you're building the thing that you're working on. You've got some sort of compilation and packaging step, putting that stuff together to create the final application that's going to run. You've got a web server somewhere that's serving this thing up for people to use. And you've got a user browser where it's actually running. And even for mobile applications, those that are using HTML and JavaScript have more or less this type of thing. Now, they may not have the web server in quite the same way, but they're probably still talking to a web server. And on the phone, it's running in a web context. It's running essentially a browser. So if we go back to all of our different myriads of pieces, where do they fit in with that simple four-piece model? 4 of these things, package management, front-end tools, module systems, and JavaScript flavor of the month, really are happening in your application code. When you get to compilation and packaging, that's where you get the task runners and build, and it may be influenced by what JavaScript flavor you have chosen. Then you've got web server. Web server, if it's in JavaScript land, is probably running using Node.js or IOJS and using one of these tools like Express or Happy. And then you have the execution environments, or sorry, the browser, which is one of the execution environments. So with this model, let's go into what are each of these different buzzwords a little bit and which ones should you care about, just so you have a place to start. So in your application code, we're going to cover JavaScript flavors, front-end tools, module systems, and package management, starting with JavaScript flavors. By the way, if you guys have questions along the way, feel free to chime up, because it's reasonably long talk, so if you save them all towards the end, you may not have the context you need for your question. So starting out, there's plain old JavaScript, which at this point is ECMAScript 5, the 5th version of the standard, and this runs pretty much everywhere at this point. So if you're writing code that goes along with the ECMAScript 5 standard, you can run it as is, pretty much any browser with Nodejs, what have you. Then there's ECMAScript 6, which is the next version of the standard, which is not running on most browsers or most execution environments, but that you can transpile things into. We'll talk about transpilation later. There's CoffeeScript. There's TypeScript. There's Dart, and there's probably a few others that I've forgotten. This is a broad talk, so I'm sure I'm leaving stuff out. So even with that, you're just kind of sitting here saying, okay, what are all these things, and why the heck do I care? So the easiest thing to get started is just ECMAScript 5, plain old JavaScript. You don't have to have a build step. You can open up your browser console and just start typing stuff away. You can run it in Node.js. Easiest place to start, and most of the examples you're going to find online that are at all old are probably using ECMAScript 5 or earlier. They'll run with ECMAScript 5. ES6 is where the world is going. This is the next thing. The browsers are all going to support it eventually, and there's tooling that lets you write your code using ES6 now, today. CoffeeScript is popular among Ruby developers, and despite being a Ruby developer, I don't understand why. But many of you have probably encountered it if you're working in that context. Yes, question? So for all of these, anything except plain old JavaScript, you're going to have a build step that basically compiles it down to ECMAScript 5, which will then run in any of these execution environments. So CoffeeScript, there's a CoffeeScript compiler, actually I think there's several, that you run, compiles it down into JavaScript, basically treating JavaScript as the assembly language. Yes? Currently, yes, because that's a good question. I don't know if there is currently a yes. Okay. Okay, so yeah, you cannot polyfill it. You need to compile it down. There's enough syntax changes and things like that.
What about debugging? Do you have to debug in ES5, or can you see?
This is a good question, and something I will discuss in a moment. Okay, because there's a very important step there. So we'll get back to that. The next language, a little bit, is TypeScript. TypeScript is actually a superset of JavaScript. Anything that you have in ES5 will run within a TypeScript environment. It's valid code, but it adds a layer of strict typing and structure that you can use. And then Dart appears to be a little bit orphaned. Dart was Google's take on, we're going to build a new language that compiles down to JavaScript, and as far as I can tell, Google is using it and no one else is using it. And some of the tools that you may use, and some of the things we're going to talk about later, emphasize one flavor or another of JavaScript. So as we go down and we start talking a little bit more about the different front-end frameworks, some of them emphasize more or are built in one of these flavors of JavaScript. And so if you're really excited about, for example, Angular, and you want to do Angular 2, they're building that in TypeScript, so you may want to get on the TypeScript bandwagon. One thing, sorry, that's going to get to debugging, and we'll talk about it later, is with all of these, your tooling becomes really important. So if you're not just using straight ES5, you're going to need a compilation step, and you're probably going to want to have source maps or something else that lets you get your debugging to happen in the original code that you're writing in, rather than trying to figure out, okay, where does this JavaScript line up with that? You want your tooling to handle that for you.
you know, mention of that subset of JavaScript, I forget what that name is now, that Firefox has that runs super fast.
ASM.js. Okay. I'm not going to cover that right now, but there is an effort to try to make JavaScript faster. It's already pretty fast, but to create a subset of the language that can be compiled essentially to be extremely fast. Firefox is leading that up. That's called ASMJS. It's actually a strict subset of ES5. So if you're interested in that, check out asm.js. So let's talk a little bit about the different front-end tools that you might need. So this is what might I build my front-end client-side application in. So anything talking about JavaScript, you'd probably be neglectful to not talk about jQuery. So we'll talk about jQuery, Backbone, Angular, Ember, React. These are a lot of the big ones. I'm sorry, Meteor fans, I don't consider it big yet. jQuery. jQuery is really the browser API that should have been. It makes it super easy to do DOM manipulation, which if you're brand new to this, you may not know what it is. The DOM is the way that the browsers represent what's showing on the page. They compile HTML down into this DOM, which is Document Object Model. That's what they use to display things. The APIs defined for accessing that are a little awkward, and they were different across all the different browsers. And jQuery unifies them and makes them clean in a very nice way. It's actually used on over 60% of all websites out in the world. I found some data on what frameworks were most used, and I was like, okay, some of these popular ones are going to be up there, Angular and Ember and whatever. Nothing else gets above 8%. jQuery is on 60% of websites in the world. It's easy to learn, and it's easy to use. Next, let's talk a little bit about Backbone. So Backbone is a lightweight, minimalist MVC. It's pretty straightforward to learn, and as I said, it's minimalistic. It doesn't provide very much structure for your application. It just provides you with tools that make it easy to build a structured application. jQuery works really well when you're doing simple applications, and when you start to develop something that's doing a lot of logic on the client side, you quickly end up with spaghetti code where you're like, okay, this is listening to this event, and this is listening to this, and we're manipulating this over here and this over here. Backbone lets you really build more of a true application, an application structure, rather than just manipulating the way things are laid out. The next step up the ladder, I guess these next three are all a little bit more complex, is Angular. Angular is a very opinionated framework. It's got a huge community. It's backed by Google, and unlike Dart, it has taken off. It's very structured and written for testability, but it has a big learning curve going from novice to expert. There's pretty good documentation for getting yourself going with Angular. The learning curve from nothing to doing okay seems to be pretty good, and then there seems to be a huge fall off of getting to expert. There's a lot of really deep details that are pretty challenging for folks to figure out. Version 1.0 is written in JavaScript. They've announced version 2.0. I don't know what the status of that is, Abishai.
Incoming.
Incoming.
Still no release date.
With no release date. 2.0 will be in TypeScript, and with no backwards compatibility. So if you have a 1.0 application, you either rewrite your application or you stay in 1.0. Yes, sir.
Is there any relationship between Angular and Dart? Are they like two separate projects?
Two separate projects as far as I know.
Would you say that testing in Angular is easier on Chrome than the other browsers?
I would say that testing on anything is easier in Chrome than the other browsers. The next framework I want to talk a little bit about is Ember. It is also a very opinionated framework. It has a big community focus, as contrasted with Angular, which is really driven by Google. Ember is very community driven. They have a very open process. It has a big learning curve, and while that's come down some, it still appears to be true. Their documentation is not as complete as Angular's, and people seem to have more of a challenge really getting going with it. They've got a big focus on performance. Some of the initial decisions were made very much from a performance standpoint, and when they see other frameworks doing things that give really good performance, they try to adopt those. In fact, they have really been focused on absorbing many of the best concepts from other frameworks. So one of the cool things with all these different frameworks is as they're going on, they're learning from each other. Angular's pulling in a lot of things from other frameworks in their 2.0 rewrite. Ember's doing the same thing. They're pulling in the virtual DOM idea from React, which we'll talk about in a little bit. They're pulling in some elements from Angular. They're doing all sorts of stuff and kind of sucking it into the framework. Yes?
Can you define opinionated framework?
Yes. An opinionated framework is one that has kind of a right way and a wrong way to do things. So they have strong conventions, and if you're not writing your code and your application structure in that way, it's very challenging. So Ember, for example, has moved to the point where they even will strongly suggest what your file system structure should be, how things should be laid out, how they should be named, what all the interactions between components more or less look like, as compared to Backbone, which says, here's a little thing for doing a model. Here's a little way for doing a collection of models. Here's a little abstraction for how you might do a view. You get to decide how they interact with each other and how they're going to work. Does that answer your question? Cool. And the other thing about Ember is that they have jumped in headfirst on ES6. So all the latest Ember builds are really pushing you towards using ECMAScript 6. Their build tool has already got the transpiler in, so they're really pushing forward on that ecosystem rather than a TypeScript or CopyScript or Dart or any of these other things.
So if you're writing Ember, you have to actually compile it?
Certainly if you're using the most recent builds, I believe you do, but I don't know if you have to. I think there may be other ways.
It depends on if you're using Ember CLI or not.
Okay.
You could still use Ember in
Okay.
certain versions of Ember, and then you could just, put it all in a tag.
Yeah. So there are ways around it, but it is not suggested, not the way the community is going. In fact, most of these, as the front end becomes more complex, more and more people are tending towards a build stage, which makes sense, right? The complexity on the back end is why we have build stages there. You're putting together a lot of pieces, and so as we move that complexity to the front end, it makes sense that we're going to want to do things that are a little bit more structured and complex and require some sort of build. The last front-end framework I want to talk about briefly is React. React is view layer only, so it doesn't have that model layer that some of the other things do. It's really just talking about how are we rendering this stuff out. You can actually use React with Backbone models or other things. It's built and used extensively by Facebook. And it takes a very different approach to bindings and state and the way that you really write your view of your application. That is pretty interesting, but definitely requires a mind shift. I actually really like, I have not developed anything in production in React, but I've played around with it a little bit, and I really like the mental model there, and I think it really, if you haven't checked it out and you're reasonably comfortable in JavaScript, go check it out, because they're doing some really interesting things. And it's very, very fast. That being said, there's been some interesting commentary about it. How fast is it relative to things like Angular or Ember? The thing that it does, you can tune any of these codes to an extreme amount to get them really fast. You can tune your Angular application, you can tune your Ember application. What React does is it's very fast, sort of in the default way of thinking about it, and lets you not really worry about the speed in the same way that you have to with some of these other frameworks. Though recent Ember builds are trending in that direction as well. So, overview of what we've just covered, front-end tools, which is probably what most folks in here are working with, though not everyone. If you're just getting started, start with jQuery. 60% of websites in the world, this is the most popular JavaScript thing in existence in history, so yeah, probably learn it. Backbone is probably your easiest next step. It's got the simplest learning curve to move beyond jQuery into a more structured application. Angular 2.0 looks pretty interesting, but they're abandoning backwards compatibility, so depending on how important that is for you, it may bode poorly for future backwards compatibility as well. We'll see. Ember appears to be absorbing all the different good parts with focus on maintaining compatibility. And personally, Ember is where I'm looking to learn a lot. I think there's a lot of really interesting stuff happening in that community. And then React is super cool and very different. And even if you never use it in production, go check it out because it's really interesting what they're doing. Yes.
So let's say that you have a very large system already using jQuery everywhere. If you had to start to invest into one of these other tools, because jQuery has a ton of plugins that are already so easy to use.
Yep.
But like you said, sometimes it's difficult to deal with event firing up everywhere.
Yeah.
Which one are friendly to still use jQuery with, or which one?
I would probably start with Backbone. You can continue to use jQuery with the other frameworks, but they require differing levels of buy-in to get started. So Angular you can use in sort of a component way where you say, okay, we're going to make this thing in Angular, but we don't have to make our whole app in Angular. But if you want to include jQuery within your Angular use, you've got to do some magic. There's some extra work you're going to do. Whereas with Backbone, it's a pretty simple step where you're just adding a little bit more structure, and you can actually end up still doing much of your DOM manipulation in jQuery, but have a little bit more structure to work with it.
Word of warning with Angular, if it doesn't know things are happening, it acts really weird. So if you make a component Angular, it's only Angular. Don't screw with it in any other way.
Yeah, so I think Backbone's going to be your easiest migration path and your easiest learning curve.
The one thing to add to that is, if you're working with Angular or Ember or React, you do have to sort of buy into the idea that you're going to refactor anything that you've built already for whatever existing technologies are out there. Backbone does have that much easier migration path because it focuses on a very narrow aspect of application development. Because it doesn't do view stuff, it's really just like my models, I have a couple of views that I can throw up. You can hand those off to jQuery and let jQuery do its thing, whatever it's already good at. Something to watch out for.
Thanks. Any other questions? Front-end tools and frameworks? Next, let's talk about module systems. JavaScript is special when it comes to modules. Most languages have some idea of modules, but with JavaScript, at least originally, it did not. And so there have been multiple approaches to how do I write a component of JavaScript. And even some frameworks have derived their own way. So jQuery has a plugin system. This is how you write a jQuery plugin. Angular has all these different things. But when we start talking about module systems that work JS-wide, not specific to one framework or another, but can be used with those, there's really three different big picture things that we'll talk about. One is called AMD, Asynchronous Module Definition. Require.js is an example of it. Another specification is CommonJS, which is what Node modules use. And then there's ES6 modules. So AMD is an asynchronous definition. It was designed and is really suited for the browser environment. We're not going to go into too much detail on these, but actually before I jump in, does everybody know what I mean by a module definition? Yeah? No? Essentially, a way to compartmentalize code and declare dependencies between it. So say, this depends on this, please load this for me, and then let me run one. So AMD is one approach to that. It's asynchronous. Lets you define a set of things and they'll go off and then they'll come back and then let you keep going. So very suited to a browser environment where everything has to be asynchronous. CommonJS is a synchronous approach. It will pull everything together at once, but you can get package it up so it works better on the server where you don't have random delays happening, but you can package up CommonJS modules or Node modules for the browser using Webpack or Browserify, which are a couple of build tools, which we'll talk about in a sec. And then ES6 modules are the future. This is the first native to JavaScript true module system. I think eventually we're probably all going to get everything working on that front. So let's talk about package management. Now that you have these modules, how are you distributing them? How are you managing versionings? That sort of thing. There's really two tools out there. There's NPM, which is the Node Package Manager, and Bower. Node Package Manager, as you might expect, these are packages for the Node environment. It defines a way of versioning and dependencies and that sort of thing, and then Bower is the quote-unquote front-end package manager, which was developed not even looking at Node really, but for how do I, as a front-end developer, manage all these things that I'm pulling into my app and not just dump them all in vendor and include them in script tags. I'm not going to go into these in great detail. I will say that they both have their challenges. If you're coming from a language with a robust package management system, like for example Ruby with bundler, you will be disappointed by both of these. But as some of you saw my talk last month about npm shrink wrap, there are things you can use to get around them. They're decent. If you're in a Node environment, if you're doing a build step, I actually much prefer using npm and npm alone and then worrying about browserify and things like that to get things up on the web. Bower is a challenge to work with, and it has a lot of holes in it. However, if you're not already using npm, Bower is probably easier to integrate into an existing environment. All right, application code behind us. Let's move on to compilation and packaging. When we talk about compilation and packaging, there's really three big things that I want to talk about. So there's minifiers and concatenators, which if you're coming from a non-JavaScript background, you're saying, what? What are these things? There's compilers and transpilers and stuff for putting things together, and then there's task runners, which are what weave everything together. So minifiers and concatenators, well, they exist to minimize the number and size of web requests. Since in a client-side application, we're sending everything over the wire, it's valuable to both reduce the number of round trips that we have to do and reduce the actual weight, the size of the thing that we're sending. And so these things rewrite JavaScript and CSS for that matter, but in JavaScript they change the names of all internal variables to be as short as possible. They get rid of white space, they move stuff together, and then concatenators put everything together into one big package so that you only have to do one request over the wire. Source maps, which we talked about a little bit for flavors of JavaScript, here become even more important because suddenly the errors that you're getting on the web are to these completely renamed variables. The line numbers have no relation to your original source. It's probably all on one line. And so using a source map, which can be automatically generated by your build tools, to map back from this error, this location, to where it is in your original code is crucial in order to be able to debug your code. And source maps are really quite interesting. So most of us who are doing a lot of JavaScript development primarily use source maps in development. Right? We're using a source map while we're doing our development, but then once we ship it off to production, we don't worry about it too much, especially because we don't necessarily, one advantage of minimizing and all of this is while you can't make JavaScript truly private, you can make it a little bit of a pain in the ass for somebody to see what you're doing. However, something I've learned recently is you can actually keep a private source map. Take those errors back and run a node process to say, okay, these errors that are happening in production, I'm going to map them against my private source map, and they'll tell me where they're happening in my production code. So you can actually use these things in a private way as well. Compilers and transpilers are how you get from all those different flavors of JavaScript, from ES6, CoffeeScript, TypeScript, whatever you want, down to your plain old JavaScript. And these typically run first in your build chain. And, as mentioned, source maps in this example are doubly important because you don't want to be debugging generated code. You want to be debugging the code that you wrote. Task runners are what are going to do this for you. We're going to talk about three of them real quickly: Grunt, Gulp, and Broccoli, which I understand is not actually a task runner, but it didn't fit better anywhere else. So Grunt is the most popular task runner in the Node world by a pretty wide margin, at least 2x. It's a configuration-based approach using JSON objects, and the communication between different tasks that you're running is via files. So if, for example, I have a Grunt task that has two things that it needs to do. It needs to do, for example, concatenate, or minify and then concatenate. It's going to take a bunch of files, minify them, write them as files. Then the next task will pull those files back in, concatenate and write another file. That's the way that the tasks communicate with one another in Grunt. And I don't know if this is, it looks moderately reasonable, readable. This is what a Grunt file, sample Grunt file looks like. So you're basically creating, you're doing a little bit of JavaScript, but you're really just passing this massive JSON object off to Grunt and then saying, here's the tasks I want to do. Next one is gulp. Gulp is the second most popular Node task runner. They take an approach of code over configuration. So rather than having this massive JSON configuration object, you're going to write code that is explaining what it is that your tasks should be. And the communication between tasks is really as pipes rather than files. So instead of reading a bunch of files in, doing something on them, writing them out, reading them in again, doing something, writing them out, I'm going to read something in, do stuff to it, and then pass it on with a pipe to the next step in the chain, which if you're doing a long pipeline can really add up in terms of speed. It can speed things up quite a bit. Sample gulp file looks something like this. Do this thing, pipe the results to this thing, pipe the results to that thing, keep going. The final one that I want to talk about is Broccoli, which is really not a, it's a build tool, it's not a task runner, it's a little bit more specialized. So you can use Grunt and Gulp to run any sort of tasks you might want. They are commonly used for build, but you could also do it to replace other things in your system. You could use it, I'm blanking on a good alternative, but because all the alternatives I'm thinking are build tools, but you could use it to define tasks that you might want to run in any circumstance. So Broccoli is really a build tool, only works for build as far as I know. It's the newest of these three, and it's still a little bit immature, especially on Windows. In fact, I think it runs colossally slowly or crashes on Windows. And it uses a tree-based system. So instead of saying, here's these things, pipe them over here, here's these things, pipe them over here, it says, okay, this is a tree of stuff that is, say, CoffeeScript. I want you to treat it this way and combine it with this tree of things which are written in this, and this tree of things that are written in that. And so a sample Brock file might look like this, where you say, okay, I have this tree over here, I have this tree over here, compile them, and then merge them together. All right, big picture, what do you want? Well, Grunt is good for beginners. It's the most familiar style for most people coming from build tools. Most build tools historically are pretty configuration driven, and it's the one that has the most stuff out there. Gulp is good if you're coming from more of a Linux background. You're used to thinking about things as piping stuff from here to there, and also if you prefer code over configuration, which I do. I'm a big fan of, I think better in code than I do in what are all these configuration steps, and so I prefer Gulp. And then Broccoli seems to be the next big thing, so if you're already an expert on Grunt and Gulp, go check out Broccoli. Try it out. It's blazingly fast. It's early enough that you can still get involved as a contributor without having to find something pretty esoteric. Okay, 2 steps out of the way. On to step 3. They get smaller though, so we're getting pretty good. So on the web server, there's 2 things we want to talk about. There's execution environments, and there are the actual web server software packages. So execution environments, there's browsers, but we're going to skip that because right now we're talking about server side. There's Nodejs, and there's this funky thing, IOJS. What's that? But we'll talk about it. So Nodejs, who here has never used Node? Wow. Okay, that is a very different audience than the last time I gave this talk. So Node.js is a server-side JavaScript execution framework built on V8. We're just going to skim right through this because you guys are all familiar with it. It is an asynchronous event-driven framework, and it defines its own module systems. IOJS. Who here knows what IOJS is? Okay, I feel better. I'm actually giving you information. IOJS is a fork of Node.js, and it moves much more quickly. It was actually forked because the 5 out of 6 of the core contributors to Node were dissatisfied with the management of Node, which is under Joyent, which is a company. And so they said, screw this is moving too slow, there's too much bureaucracy, and it's too much owned by one person. We're going to move it out, move much faster, and make it more of a community-managed process. They've been pretty successful with that. It's let them keep up with changes in the V8 much more rapidly, all sorts of other things, but it's also confusing. Should I use Node? Should I use IOJS? IOJS is compatible. Node already has this mind share. But luckily, they're in the process of merging back. Everybody realized this is a problem. We've got to fix it. Joyent set up the Node Foundation to have an independent, non-corporate manager for Node. They've been agreeing on bylaws. Everybody's on the same page now. Now they're just figuring out the details of how do we merge this back. Node 3.0 will be the merge of Node.js and IOJS. So you can probably forget that we ever talked about IOJS.
It was politically stuff.
Yeah, well, and in fact, 2 months ago when I gave this talk, that last line said they will probably merge back, because it's really just in the last month that they've said, yes, we're actually going to do this, and everybody's agreed. We've figured out what we're going to do. Web servers. Express is the most common one that most people have probably heard of. Happy, I'm going to talk about, especially because it's developed by some folks here in San Diego. And Koa, which probably nobody's ever heard of. You guys, who's heard of Koa? Oh, we have a couple. Okay, when I started looking into web servers, I was like, is there anything else out there? Turns out there is. So Express is the de facto standard. This is what most folks who are doing a node-based web server are using. It's very code-driven, it's very simple, it's pretty mature, works pretty well. If you're coming from a Ruby world, it's similar in style to Sinatra. Happy was developed by Walmart Labs, I believe in the office up in Carlsbad. We've had a couple of folks from there give talks about Happy. It's more of a configuration-based approach, and their take was, we want something that's more amenable to the enterprise, to folks who are used to being able to configure stuff and be more plug and play on a configuration basis rather than having to write a bunch of code. Seems to be doing all right. They've got pretty good uptick. Seems to be pretty mature. Koa is a minimalist successor to Express. So if you think Express is not minimalist enough, I want to make it more minimalist, check out Koa. It's actually being developed by the original developer for Express, who's like, I'm done with Express. I want to do something new. I don't know much about it, but it seems interesting. Finally, we're on to the user browser. This is the traditional place where JavaScript runs. This is why we all got interested in JavaScript in the first place, is we've got these great web pages that are now accessible to people. Let's make them do something. But these days, it may not be that old traditional browser. This may not be the desktop browser that we grew up with. This could be on a laptop, it could be on a mobile browser, but increasingly commonly, it's even embedded within a mobile application. When you talk about hybrid apps versus native apps, people think, oh, am I developing my whole application using something like Cordova and building everything in HTML and JavaScript? But something I've learned is that a surprisingly large number of native apps have an embedded web view that is rendering HTML and JavaScript from somewhere. This is a very common use case where your JavaScript is running inside of a mobile application. And different browsers obviously have different levels of spec support. This has become less and less of a problem as IE has lost influence and come up to more modern standards, but it is still a problem, particularly if you're having to support old mobile devices. Mobile browsers are their own new headache. You'd think that Android would just be running Chrome, but if you're going back a few generations, you have Chrome and you have their native browser, which is some version of WebKit, but it's different per phone and not the same as Chrome and not supporting the same standards. So it's a headache. But if you're worrying about cross-browser support, typically you want to support the last two versions of each browser unless you have other business reasons otherwise. And the quickest way to get to cross-browser support is to use frameworks that have good cross-browser support. Essentially let somebody else worry about it. Things mostly break down on the bleeding edge. So if you're trying to use the latest cutting edge browser API, JavaScript API, HTML5 audio, something like that, you're going to have to do a lot of cross-browser testing. If you're doing something that's more traditional, you're doing an interactive application, but it's using the DOM straightforwardly, or it's just using a framework like Angular or React or Ember, you're probably okay. So really, we've gone through this talk. the premise was if you're just getting started in JavaScript, where do you start? You may not be any further along, but the easiest thing is actually just to let somebody else choose for you. So two final things I want to call out for you are Yeoman and Ember CLI. Yeoman is an application templating framework, essentially. It's a tool for creating boilerplates. It's a tool for creating generators. So you install Yeoman as an NPM package, and you get access to, I believe it's over 1,600 different application frameworks where people have made these choices for you. They've said, okay, I'm going to create a package that just works, that's using Grunt for build, and it's using NPM with Express, and it's serving up an Angular page, and it's using Mongo for the database, the mean stack as a Yeoman generator. You install it, you're ready to go. And what that lets you do is not have to figure out how all the pieces work at once, because out of the box you have something that's sort of working. You put that in, and then you can say, okay, this is the one I'm focused on right now. I'm going to figure out how do I really make Angular do what I want it to do, and let the other pieces just kind of do their own thing. And then once you've got that figured out, you say, okay, now I'm going to really work on configuring my build scripts and really learn about Grunt and how that works, or gulp and how that works. And then, so Yeoman is most of the world, and then Ember's building their own because they're special. So Ember CLI is essentially that. It's defining a set of conventions, layout, file system layout, build tools, etc., for an entire Ember-based stack. And this is an appropriate place to go to. Yes. So yes.
Does Ember CLI contain some kind of lightweight server that will serve up all your assets?
Yes, it does. Yep. Yeah, it's got a lightweight, I believe, Express-based server. Yeah. Beg pardon? Ionic, yes. So Ionic is, yeah, it's kind of a special case, but you're right. So Ionic is a Cordova and Angular framework that gives you an application structure and all those things for building mobile apps using Angular. Yes.
So iOS apps come from the iTunes store, and there's a lot of money to be made doing that. Likewise, Microsoft with other Windows 8 workstations and things, they have their Me Too version of that with the Windows store. Google also in the same place. Is there something that you can get from each of these native providers? And it's sort of not a browser, but it really is a browser, wink, wink. And inside of that, it provides a platform of, let's say, 6 or 5 or something, so that we can target a native-like non-browser thing.
So there's a few different ways you can tackle that. So let's take the example. I don't know as much about the Windows stuff, so I'm not going to target that, though I believe they let you do HTML5 and JavaScript native applications.
All these different platforms have their own special JavaScript running, their own script environment.
Yeah.
You call it an application, but actually it's not an application. It's actually in its own isolated,
it's got a sandbox.
Script-based sandbox to run things in. And it's kind of a moving target, I guess, between different stores, whether they'll accept JavaScript-based applications versus using compiled code.
Yeah, so there's a few different things to cover on that. So talking about, in particular, iOS and Android, which I can talk a little bit more about. Depending on what level you want to go to, there are different options. So one option that I've talked about and that a lot of folks use is Cordova. Cordova is what PhoneGap turned into. It's now an Apache project. And what it provides is essentially a packaging where you put an HTML and JavaScript application in a quote-unquote embedded web view, but give it then access to native functionality via a JavaScript bridge. So you can basically, there's a set of existing plugins that have a native implementation and then a JavaScript interface. And then you can write your own that have a native implementation and JavaScript interface to give your embedded web app access to any sort of native device functionality that it needs.
Is it seen then in a browser?
It is seen, so it is rendering it in an embedded browser, but it feels like an app, more or less.
The user wouldn't.
Yeah, a user wouldn't know.
It's kind of a stripped down version of the full browser. So it's like a browser, except that it doesn't have things like your address
Yeah.
You know, like URL thing at the
So-
top and stuff like that.
But your environment feels like a browser with special access as a developer. Now, there are some challenges depending on the complexity of your app or how many native features you want in it, that may or may not work that well. But for example, Ionic is using that approach, where they're using Cordova and they're really packaging it up with Angular and some of their own things to make a
What
really
is the
straightforward.
delivery mechanism from programmer
It-
to
You
the
package
person
it up
with the
as an
phone?
application, and same as you would a native app. So you compile it down. Cordova has a build tool. You compile it down and package it up as an APK or an IPA or whatever is appropriate, and it goes through the App Store.
You can
Uh,
even make desktop apps that then browser apps with Cordova as well.
There are also tools like Titanium, which is not using HTML but is using JavaScript. So Titanium is essentially a set of node packages that use the embedded JavaScript interpreter but run in more of a native context and reference native UI components. So Titanium has pulled together a bunch of different things for creating an iOS application. I think they also do Android. And they're generating native UI, but they're using JavaScript as the execution environment for you. And they're running using the built-in JavaScript interpreters. So that's a slightly different, it's more using, so it's less like building a web application that happens to run as an app, with some native access, and more like building a native application using their typical frameworks, but happening to use JavaScript as your development language. So those are two things that I would look into. Yes, sir.
Going back to your web servers slide section,
Yes.
you have Express, you have Happy, you have Aquila. Aren't those really just running inside of Node, or are they running separately from Node itself?
Oh, absolutely. Node is simply an execution environment. So, for example, the other community I know the best is the Ruby community. So Ruby is a language and execution environment, but you would, if you're running a web server, you would use something like Thin or Unicorn or something else, and you would execute that to run some sort of server framework like Sinatra or Rails or something like that. So Express is the equivalent of a Sinatra or a Rails. So Node is the equivalent of Ruby and its environments, or in Java, Node would be the equivalent of the JVM in Java, not Apache or whatever. I don't know. Apache's probably not.
I think a better way to look at it would be like following the JavaScript and jQuery. So everything that Express does can be broken down into a native node. You write all of the stuff in Node. It's just like jQuery. Less steps for you, just all the done by the
I'll just think of it as a cross-platform execution environment.
Node is, yeah,
Yeah, no.
exactly.
So if you're trying to build apps at scale, do you have any tips for that, or which direction to
So, generally speaking, I recommend using frameworks. So I would not write a web server using raw Node. I would probably build it in Express if I'm doing it in JavaScript, just because they've already done most of the work of tuning and optimizing all the common things that you're going to do and figuring out how they should work. Does that answer your question? Yes.
What do you think about a feature now bringing 3D elements in the browser? GeoGeo, Canvas, and Figures. Do you think it's a feature that also bringing a bunch of games and
Yeah, that's a good question, and an area that was totally neglected in here. I didn't talk anything at all about kind of gaming technology. I don't really know enough to say there. It seems like it's likely to stay a little bit behind native functionality, but it's probably going to be good enough for reasonably interesting
What was
games.
the question?
Oh, sorry. The question was, what do I think about 3D rendering in the browser using WebGL and other things like that? And is that going to become the place to go for high-end games? Is that correct? Yeah. And so I think for the very high end, it's still not going to be there because you're always going to have that intermediation layer between the browser and the OS, and it's going to get better and better. and it's going to give you more and more native access to different GPUs, but it's always going to be a couple generations behind whatever the native stuff is going to support. So I think we're going to get to the point we can get really good 3D stuff in the browser, but then the native is going to be one step further beyond. Yes?
What's with Google pushing both Polymer and Angular?
You got me. Google is a massive company with many different pieces. Yes?
I come from the world of databases, and back then, for example, you might have to create a new user, you might create 5 records in 5 different tables, and the whole thing is treated as something that has to happen or not happen. What I'm seeing here with kind of Node and what's going on is that some action could happen where a scale up or a scale down or a restart, or you change something on Heroku, and it's restarted your entire web app. And it doesn't necessarily keep the 5 things together as an atom of work. Are there any pieces within here that help with that and keep a transaction sacrosanct?
Yeah. So that's a good question. So first of all, if you have stateful data that you need to keep, for example, a database, I recommend using a database and not Node. But there's a bigger question there, right? Because a bug that I have seen is where you have, for example, with all of these interleaving requests, if you have any sort of global state in your server, you're going to have race conditions, you're going to have things touching it. So you have to start thinking about things in a much more functional way, or an object-oriented where you're instantiating everything. So either you need to have, if you have a bunch of things that are hanging together, they need to be attached to an object that's getting passed around with that state and is only for that set of things that are going on, so that you're not having, this thing accesses this and changes it, and then, we got interrupted, so it's sitting over here and something else modifies that, and then when it comes back, it's trying to deal with it. Like, you need to have a dedicated object following through your 5 steps, or you need more of a truly functional approach where everything depends on input and output.
I'm kind of wondering, is there one of these frameworks or something that has figured this out and they're a little farther down the line?
When you get into this kind of database, okay, I forgot exactly what the name of the theory is, but there's a principle of there's three out of three desirable objectives in databases. You can only achieve 2 out of the 3. I forgot, one is reliable, another is consistency, another is
segmentability, but
something like that. And so basically, when you start talking about some of these databases, especially NoSQL databases and distributed databases or distributed node databases, these are the things that you decide upon when you decide what database you want to store your data in, and you just have to accept whatever compromises and recognize the compromises that you make.
Yeah. So, also getting back to, I'm not totally sure I understand all the context behind your question, so maybe we should talk a little bit after this. But generally speaking, anything that you're going to require true transactional support on, probably, like if you're writing data or something like that, like actually reference a database, so use Postgres in the back or something.
Well, implicit in that is, and then there's a MongoDB or something.
I wouldn't use Mongo though, but that's it. Well, for exactly this reason, it's been shown to not actually be able to keep things that well defined. But so you have Postgres behind it. So basically, load your state, encapsulate it in something that you pass along, and then write your state if you need to. And I'm not sure that.
You're saying basically create a transaction log and then know about. I just woke up again. Look at the transaction log. Finish this up, and that's what a relational database is.
Yes, but not really. So actually, let's take this offline because I think it's going to get a little bit beyond the scope of this.
For a lot
something else to keep in mind there is that if you start talking about one type of database versus another type of database, it's really the purview of databases. Node will talk to either, and it's really just a matter of building an app, structuring your app in a way that lets you build for the problem you're trying to solve.
By the way, you can write stored procedure JavaScript and PostgreSQL.
That's another thing. You could move your whole application down into the database if you want to. No, I don't know that I'd recommend it. Any other questions? All right, so to conclude briefly, JavaScript is where things are going. All those trends were up and to the right. This is the future, and you're here now, so I'm going to see you there. Thank you.